Okay, in this video we're going to be answering GCE 2020 question 2 with mechanics. So the question reads, given that y equals to ln bracket open 4 plus x squared bracket close, find the derivative with respect to x, that is dy dx. 2 marks. B, the equation of the tangent and the normal to the curve y equals to ln of 4 bracket open 4 plus x squared bracket close at the point where x is equal to 1. So sub 2 says solve the differential equation dy on dx equals to xy minus x, given that y is equal to 2 where x is equal to 0, express y in terms of x. So we're starting with question 2 sub 1. We have been given our function to be y equal to ln of 4 plus x squared. So we have to look for the derivative of this function with respect to y, with respect to x. So we know that y prime, which is still the same as dy on dx, will be equal to the derivative. So before going to this, I would like to draw your attention a bit on this point that if you are given a function, let's say y equals to ln of f of x, so y prime will simply be f prime of x divided by f of x. So in this case, what do we need to do? We simply need to look for the derivative of our function divided by the original function. So we know that differentiating a constant gives us 0, plus differentiating a quadratic, which is squared, we bring down the power, so it will be 2x, and we subtract the power by 1, so 2x to the power 2 minus 1, which is going to give us 1, which is going to give us 2x. So now divided by the original function 4 plus x squared. So that's our answer. So finally our answer dy, so our answer dy on dx will simply be equal to 2x divided by 4 plus x squared plus x squared. Now that is our final answer. So question 2 states that the equation of the tangent and the normal to the curve y equals to ln of 4 plus x squared at the point where x is equal to 1. Now the equation of the tangent, we know that to get the equation of the tangent, the general formula is given as, so that's our b is given as y minus y1 equal to mt into x minus x1. So where mt, we know that mt is dy on dx, that is the gradient of the tangent. So the first derivative gives us the gradient of our tangent, and now our y1 will simply be the value of y when x is equal to 1. So we already have our mt, so we know that from the above, we know that when x is equal to 1, if x is equal to 1, therefore mt will be equal to 2 divided by 5. So that's our mt. Now to get our y1, so this is actually our x1, so to get our y1 we simply substitute from y equal to the ln of we know that is ln of bracket open 4 plus x squared. So when x is equal to 1, comma, we're going to get y1 will be equal to ln of 5. So now putting it in this our formula, we're going to get y minus y1. What is our y1? It's ln 5. ln 5 equal to mt, which is the value we got here, will be 2 on 5 into x minus x1. Now our x1 was 1, so to express, we need to express our answer in the form y equals to mx plus c, where m here is our, let's say, mt, where mt is the first derivative, which is the gradient of the tangent, c is the y-intercept. So now simplifying that function, we're going to get y now will be equal to 2 divided by 5x now plus ln 5 minus 2 divided by 5. So if we break it down, we see that this is a constant. So and it is of this form. So this is our answer for the first part. That is, this is the general equation of the tangent. Now to get the equation of the normal, what do we know? We know that the relationship between the gradient of the tangent, so m of tangent times m of normal, should give us minus 1. So from here, to get the gradient of the normal, we simply have minus 1 divided by the gradient of the tangent, So this implies that our m of normal will be equal to negative 5 on 2. So we are going to follow the same steps. We know that, so we are going to apply this same formula that we got here. So we are going to apply this. So we know y minus y1, our y1 was ln 5, that is ln 5, equal to m of, this time around will be m of n, which is m of the normal, not more the m of the tangent, minus 5 all over 2 into x minus x1. So our x1 was 1, so we simplify our value. So we have y now to be equal to minus 5 on 2 x now plus 5 on 2 plus ln 5. So that's our result. So this is our final answer. So now we have equation 2. Solve the differential equation dy all over dx equals to xy minus x. Given that y is 2 when x is 0, express y in terms of x. So solving differential equation, we need to know that at this level we can use separation of variables. So whenever a differential equation is given to you of this form, dy of d all over dx, which is equal to xy minus x, so we are going to solve this differential equation by separation of variables. So just like we used to do in subject of formulae, we're trying to bring all similar terms on one side and bring on one side and the others on the other side, so that we can simply differentiate or integrate. So now x is common, so we have dy all over dx to be equal to, we factor out our x, we're going to get y minus 1. So we discover that dy divided by y minus 1 should be equal to x dx. So what I did here is I simply divided all through by y minus 1 and multiplied all through by dx. So doing that, we're going to arrive at this point. So here we're going to take our integral sign. So this is what we will need to integrate. So now the integral of 1 divided by y minus 1, we discover that differentiating the denominator y minus 1, we're going to get 1, right? If we get 1, which is the coefficient of the numerator, therefore the derivative of dy divided by y minus 1 is ln of y minus 1, which is equal to the derivative of x will be simply x squared divided by 2 now plus a constant term c or k. So I'll prefer to use k because k is my academic, starts with my academic journey. So k. Now we need to look for the value of k given the initial conditions, that is when y is equal to 2 and x equal to 0. So if y is equal to 2, when y is equal to 2, we're simply going to get ln of 1 equal to, and x is 0, so this will be 0 plus k. So what does this implies that our k will be 0 because ln 1 is 0, so k is 0. So our final equation will be ln. So our final derivative will be ln of y minus 1 equal to x squared all over 2. Now notice that this is the answer, but it's not the final answer. So they said express y in terms of x. What we have here is the natural log of y minus 1. So to make y in terms of x, they are simply saying we should make y subject of the formula in this case. So to remove the ln function, what do we know? We know that e to the ln x is simply x, right? So we take exponent on both sides. So taking exponent on both sides here, we are going to get e to the ln of y minus 1 equal to e to the x squared all over 2. So here we're going to get y minus 1 equal to e to the x squared on 2. So this will be y now to be equal to, so we can write this as e to the x squared now all that to the power a half, so plus 1. So we can even further simplify it as y equal to the square root of e to the x squared plus 1. So that's our final answer. Okay, thank you very much for watching my video. Please, if you have any question, any GCE question, please put in the comment section below, and like my video to support me. Thank you.